So hi everyone, in this I'm going to talk about IPv4 versus IPv6. But before that, I just want to give a refresher on I want to give a refresher on what I'm talking about. So and why I'm talking about. So in this, I just show a small cluster. So every cluster in Kubernetes is has a manager and has worker nodes. Manager is basically a managed, mostly if you're taking from AWS or GK or anywhere. Managers are usually the control plane where it runs, and it's managed by the provider, cloud provider. And the worker nodes are the one which forms the worker node groups, and worker node group is where all your pods and services run. So if you can see, this is an older slide, but basically and it needs a pod network CIDR range. So this each node has its own CIDR range, as you can see, and this is IP range, and this is an IP range for this node, and that's where these are the pods. It's not just the pods, we also need IPs for the service endpoints. So where does IPv4 and v6 come in is because you need lot of you need lot of IP addresses. Yeah, and especially if you're running multiple clusters within a VPC, then at some point you can hit. That's why I just want to give a refresher, and I'm going to talk why IPv4 and why we are talking about IPv6. So, what is IPv4? IPv4 is basically what we use daily in our networking. It is the fourth version of IP, and it's basically used for networking functionality on for the packet exchange on the internet. So, IPv4 is very popular, and it has a 32-bit address scheme. So basically, if you have a VPC, so IPv4 gives 4.9 billion IP addresses, and then IPv6 is basically 128-bit address scheme, and it gives much more IP addresses. So if you I've pasted the link where it explains the difference between the two. So why IPv6 and why we are talking about it? So especially in the context of Kubernetes, right? So the issue sometimes we see is that when you have, especially in if you're using any of the cloud providers and you are using one VPC, but you're using a single VPC for a lot of EKS clusters, so at some point you will start seeing the IP exhaustion. That means the IP addresses that are being used by the pods and services on the cluster, you will start seeing the issue that you cannot deploy more pods because the IPs have been exhausted. It's because the IPv4 has a limitation, right? So at some point, if within a single VPC, this issue starts coming if you have a lot of services running and a lot of clusters within a single VPC. So that is one of the key reasons to switch over to IPv6 and see if, because IPv6, what it does, it provides many more IP addresses, and it's a little bit simpler. But from the Kubernetes perspective, we only are going about IPv6 is because that if you hit this issue and then you want to move over from IPv4 to IPv6, but moving from IPv4 to IPv6 is not yet an option. So in this, I'm going to just take an example of AWS EKS clusters. So if you have, for example, I picked this and I provided the link on the slide, and I will attach the slide and the links to the this um, recording. So basically, if you have if you see AWS EKS cluster, what it has is it has a control plane. Control plane is hosted at Amazon. So normally when we build a cluster, we don't really care about this, because this is not, we don't deploy, we create the cluster, it gets deployed, but it's a part of the AWS as a managed service. And the other thing is, when we build the worker nodes, so this worker nodes are definitely, it's recommended they have to be in at least two availability zones. So in this case, you're seeing in this diagram that there are three of them. So in this case, this is one availability zone. Now this is a single VPC. So in this availability zone, right, you have multiple, these are the nodes, and each node um, will run your pods and services. So as you can see, at some point, if you have multiple clusters, so this is just one example, but if you have multiple of these, and there is a wider VPC where multiple of these clusters are running, then that's what I'm talking about is an issue where IPv4 exhaustion issue can be seen. So what is IPv6, and has anybody started supporting IPv6? Because IPv6 started around, I think, 1999 or 2000, and some lot of products have supported, and lot of them. So Amazon just provided, this is the blog link, and they started with this, but there is no option to move from IPv4 to v6. So if you have a cluster that is running IPv4, then it's not possible. But this is the first thing they came out with, and it supports the dual stack. So what it does, it's, for example, this is your cluster, right? So in this case, your this is the EKS control plane. So this is running in the Amazon managed service, and this still will be IPv4. That's what they're calling dual stack. So, and the communication from outside to, because your NLBs and ELBs, right? So communication from outside is v4, and communication between your cluster and the worker nodes is also IP4. So where does IPv6 come into picture is this. So this is your this is our rights. For example, I'm a customer and I will set up my own VPC, and within the VPC I will deploy my worker node group. Now the worker node groups will consist of the worker nodes where my pods and my services will be running. So that is where they have provided support for v6. And what it is when you're creating, if you have already created in the past, and you always have to, you have public and the private subnets. So private subnets are to be used to deploy the pods and your services. They should never be on the public subnet. Public subnets are only used for load balancer, so your load balancer can access the endpoint and to hit the services. So where does IPv6 come in? So that's why all the, when you deploy a cluster with IPv6, so basically this, your node will still be IPv4, but the pods and services like the overlay network, which is a CNI plugin, that supports v6. So then in that case, your pod and service will all have a v6 IP address. And what's the next? Yeah, so I can actually, let me show you, if we look at the blog, and they have very good this blog explains very nicely how it is done, and you can read it. But basically, there's a ENI prefix that is required. So that is how, pod to pod communication, and um, within the cluster, that's how it happens, because every node, it gets a ENI, which is v6. That's how the dual stack will work. So what is IPv6 support? So when you're building a cluster with v6, there are certain things that are required, and the first thing is that there is something called as Kubernetes network configuration that has to be set to IPv6, because by default it is IPv4. If you don't set this parameter, it will not take v6, so it will assume that it's a v4 cluster. And again, the node instances, so now the nodes that are you're creating in the on your worker node group, right, that is the EC2 instances. So EC2 instances will still be IPv4 networking, but they should be either M6A or M61 extra large only, because of the they will have a support for v6 also, because the communication, when it happens between one part to other part, like anything across the two nodes, it has to have support for that. And that is what it is called IPv6 prefix specification. That's the ENI level, and this has to be set. So this will be EC2 instance has to have that setting. It's called, if you're using CFT, then it's in the launch template, it can be set up. Or if you're just running through command line, this is the prefix that can be set up. Again, the CNI has to be 1.10 or later, because CNI is your network interface, and that has to support v6, because pods and services are all going to be v6 IPs, and that's what we need. We need to be able to run as many pods and services, and that's why we are moving from IPv4 to v6. So that's why you need a higher version of CNI. So now the EKS cluster runs in a VPC. So VPC that you have has to have IPv6 CIDR block assigned to the subnets, because otherwise it's going to fail. So they have to have a v6 assigned, and it also has to have something called as auto assign IPv6 addresses parameter to be set, because so that means that anytime a new uh, pod comes or any new resource comes, it has to have the IPv6 address. So this feature has to be set. And some of the other things you need are, right, routing table should have routes so that IPv6 can be communicated. It should allow for routes from IPv6, and the SGs, the security groups that you have for your cluster, should also allow IPv6 addresses, because the networking between the control plane and the worker nodes is through security groups. And the last thing is the assign IPv6 address on creation. That feature is on the EC2, that has to be modified so that this is enabled. One thing that is not allowed is upgrade, as I said. So there is no way to upgrade a V4 to V6 cluster. So that's pretty much it. And this this was just an overview of why we need IPv6 and what do we need in an AWS EKS world if we want to set up a new cluster. Most of the time it is recommended, and even Amazon actually recommends it, that you should have create a separate VPC and subnets in there they have the CIDR support. Otherwise, if you use an existing VPC that has some other IPv4 EKS clusters running, because there can be issues, because it's us asking for auto assignment of um, IPs and all that. So if it's asking for that, then there could be some conflicts between the existing resources.